All right, so one thing that I want to mention, and this is very important as far as when we get to properties of matrices, is introducing the definition of the additive inverse. Just like in numbers, when we talk about an additive inverse for the real numbers, the additive inverse is a number such that you get the opposite value of the number, right? So if I have, let's say, if I have 2, right? The additive inverse of 2 is the number that gives me, when I add them, it gives me what? It gives me the identity, the additive identity. What's the additive identity for real numbers? 0, right? Because if I add -2, I get 0, right? And so this is 0 is the additive identity because anything you add to 0 gives you the same thing, right? So we get 0 plus 2 equals 2, right? Which is equal to 2 plus 0, right? So when we talk about additive inverses, they're the opposite of each other. Well, in the matrices, when we're dealing with matrices, you have a very similar definition, right? So when we have an additive inverse of a matrix, A, then it's going to be the matrix such that all of the elements of A are of the opposite value. So we denote the additive inverse as the negative or the opposite of A, right? The negative of A. So if A is defined like this, then the additive inverse denoted negative A is defined like this, where we take the opposite value of all of the elements of A, okay? And then of course, when we add these two together, we get the additive identity matrix, right? Which we'll introduce later on, but A plus the opposite or negative A will give us what? The 0 matrix, right? Which we denote just as a 0. Okay, well, no, I'm sorry. The additive, how do I do this? The additive identity matrix, okay? Which is just a 0 matrix in this case. It's just a matrix with all zeros. And so, and then of course it would have an order to it, right? Okay, that's it. So that is the definition of the additive inverse. So the next thing we're going to do is we're going to talk about properties of matrix addition.